Hi, Mr. Rabelais here with your homework helper for input-output. Now, input-outputs are really just how to solve a table. Let me show you what I'm talking about. When you have a table, you have a number in that gives you some result out. So we label this the inside. That is the outside. The 3 goes in, the 21 comes out. Something is happening in the middle. Some solution sentence is happening there. To the 3 to give us the 21. We call that the rule. And so we always have the kids write rule down the middle and then write a number sentence that solves each one of these. Now the rule can't change. The rule has to stay exactly the same. Now we know it's going from 3 to 21, so we know when the number gets bigger we're either adding or we're multiplying. So let's try adding. 3 plus 18 would be 21, but 5 plus 18, because the rule stays the same, 5 plus 18 doesn't give 35, so it's not addition. It must be multiplication. 3 times some number is 21. Well, we know that's times 7. 5 times 7 is 35. Yes, looks like we've hit on the rule, but we have to check every entry of that table. The rule is always constant. Check every single entry on the table. Don't stop at the first one. 7 times 7, 49. 9 times 7, 63, and we have solved that input-output table for multiplication. Here is a sample of another type of input-output table, but it's got some sort of graphic or a machine. The numbers kind of going in. Sometimes that throws the kids because they don't think of it as a table. They think of it as some sort of design or something, but it's the same thing. You label it the inside, and this is the outside, and the rule is in the middle. And of course it's times 7 times 7, same as the last one. Remember, the rule is always constant. It's just a number sentence that completes the number in, the number out. Again, one thing we tell the kids, a little rule to remember is addition makes numbers bigger, multiplication makes numbers even bigger, subtraction makes numbers smaller, and division makes numbers even smaller. So when that number is getting bigger, we know that we're either adding or multiplying. If the number from the left to the right in an input-output table is getting smaller, we know that we are subtracting or dividing. Remember, this is a rule. Let you look at it real quick. So here are some examples. At a real quick glance, we can tell the number is getting bigger. So we know that this is either adding or multiplying, and we can solve it that way. We know that this is getting bigger, so it's either adding or multiplying. Let's take a look here. 2 plus 4, 4 plus 4, 6 plus 4, 8 plus 4. The rule, always mark that. Mark the rule. This is the outside, inside. It's 2 plus 4 plus 4 plus 4. That solves every one. Numbers getting bigger must be addition or multiplication. 2 plus 6, 4 plus 6, plus doesn't work. Addition doesn't work. Must be 2 times 4, 4 times 4, 6 times 4, and 8 times 4, of course, is 32. That gives us our missing number. So remember, the rule has to work on every single one. It's a number sentence that solves the inside over to the outside. It's a number sentence that makes it complete. Now look at these two examples. Going from 16 to 12, 14 to 10, the numbers are getting smaller. Remember, when numbers get smaller, we're either subtracting or dividing. So let's see if this is subtracting. It's minus 4. 14 minus 4 is 10. Yes, the rule is minus 4. And always complete that number sentence. Always put your equation. 14 minus 4 is 10. 12 minus 4 equals 8. 10 minus 4 equals, the missing number down here is 6. Now this is also getting smaller. 16, 4, 12, 3. So we know that it's either subtraction or division. 16 minus what number would give us that? Would be minus 12. So 12 minus 12 doesn't work. Go back to division. You see, we have to keep analyzing whether it's addition or multiplication, whether it's subtraction, whether it's division. So we will say that this is 16 divided by 4 equals 4. Mark that the rule. The rule goes right down the middle. 12 divided by 4 equals 3. Yes, it checks out, but it's got to check out for every one. And 4 divided by 4, of course, is 1. That is input-output problems. It's a table. It doesn't matter if it's a machine, if it's a graphic, if it's got arrows, if it's got wings. It really doesn't matter. If the number gets larger from left to right, add or multiply to find the rule. If the number gets smaller, subtract or divide to find the rule. This is Mr. Rabelais with your homework helper for input-output practice.